To study about the motion, we often use graphs. Graphical method of representation of motion. Here we are having a distance time graph. So what do I mean by that? Distance is in the y-axis and time is in the x-axis. Always remember there are multiple graphs. A graph has to be specified uniquely by the y-coordinate and x-coordinate. It can be, instead of the distance, it can be speed, instead of velocity. So we'll have different kinds of graph. So here we focus on distance time graph. Let's take three conditions. Here I have got a straight line that is increasing. So this kind of straight lines which is constantly increasing will be just referred to as positive slope graph or increasing graph. So what does it represent? So it represents a uniform speed. So whenever we have a straight line, always remember for a distance time graph, it represents uniform motion. So here the distance and time comes, it is uniform speed. Next, so here we have a curve. It is not a straight line, it is just an arbitrary curve. So what does it represent? So this curved line represents non-uniform speed. And the third case, we are having a straight line that is parallel to the x-axis. So what does it represent? So this represents a body which is at rest. So what is the meaning of it? So it says that at each and every point of time, so let's say at 2 seconds, 3 seconds, 4 seconds, 5 seconds, the distance is not changing. The distance is fixed. It is as saying that the body is at rest. Now let's look at different graph. Here we are having velocity time graph. So y-axis will be the velocity and the x-axis will be the time. So let's try to analyze the similar curves for the velocity time graph. So first we start with, as usual, a straight line that is parallel to the x-axis. So for this, at different point of time, it has the same velocity. So what is it? It is uniform velocity. Or so anything, if it is parallel to x-axis, we have uniform velocity or velocity that is fixed, it's not changing. Now we have a second line with a positive slope. This line is increasing. So the velocity is constantly increasing. So what does it mean? It means straight line that is increasing. When the velocity increases, we have positive acceleration. Similarly, we can also have a constantly decreasing graph. So it's a straight line that is decreasing. So what does it represent? So this represent the velocity is constantly reducing. It is negative acceleration or retardation. So this is constant negative acceleration. Now, so I have shaded a region under this graph. It is called shaded area under the graph or shaded region. Okay. So what does the shaded region represent? So this area under the graph for a velocity time graph. Remember, this is applicable for velocity time graph. If I have the velocity time graph and if I take the area under the graph, it always represents displacement. Now I have got speed time graph. Y-axis will be speed and the x-axis will be time. So here I have got two times measured, T1 and T2. And corresponding to T1, I drop a perpendicular, I move upwards and I drop a perpendicular to the y-axis, I have V1, and similarly for T2, I have V2. So it is like saying at T1 time, it is having a speed V1 and at T2 time, it is having a speed V2. Now area, so this corresponds to the area under the graph. So if you look carefully, it looks like a trapezium, right? So the area under the graph for a speed time graph always represents the distance covered within the time duration, that is T2 and T1. And since it is a trapezium, we know the formula for the trapezium, that is half times the height T2 minus T1 into the parallel side, the sum of the parallel sides. So here it is V2 plus V1. So this is how we have to evaluate area under the curve for specific problems. Now we have got a unique shaped graph. Remember, any graph that is given to you, always remember what is the y-axis and what is the x-axis. Here, of course, x-axis is time for everything. So we will have y-axis as speed, velocity, distance. Here we have got velocity. So this is a velocity time graph. So the first is OA. So in this OA, what can we see? So in this OA, it is increasing. So it is having positive acceleration. and then AB. AB is not increasing or decreasing. It is just a constant line parallel. And we know that when this comes, the body is having zero acceleration, or we say that it is having constant velocity. The velocity is not changing. Then we can have DE. So here DE, the line is drawn downwards or decreasing line, straight line. So what can we infer from it? We can infer that it is having negative acceleration.